Hi everyone, and welcome back to my channel once again. Today we are going to see how to perform a molecular docking between a specific ligand and a specific receptor proteins. In order to do so, we need to have, for example, Chimera software or AutoDock or PyMol or Go or another kind of software uh, that we can use in order to perform molecular docking. For this video, we are going to use Chimera 1.16. Then I have the presentation of the software here. We are going to perform molecular docking between that proteins, which is the Culex fasciatus chitinase receptors. I name it CQCRO. Then it in order to study how benzoylurea insecticides are acting inside the nervous system or the cells of insect like cockroach. Then we have here a species among the active substances present in the family of benzoylurea compounds named flucycloxyron. Then we are going to perform a molecular docking between these two structures, this structure and this other structure. To do that, it's important to know that you need to create in your computer a specific folder containing the different steps, like for example the molecular docking steps and the interactions view. Containing the interactions view, you can access to that folder or to a video on how to perform or analyze interactions view inside the molecular complex through this channel. Then today we are going to see how to perform molecular docking. So you come here and we click on File, Open. We need to state the good direction where the protein structure is located in your computer. Here we are in F disk, and we can go there. Make sure that we are in F disk. Here we are not in that disk, I think. Then we come on Change Drive. We click on it. Okay, you came here, you click on Change Drive. After Change Drive, you select F drive, Chimera video, Chimera 11, and here you can have video 6, and in video 6 you can have resources. Then the pathway to the compound must be the same like in your computer. Then the pathway like that, we are in drive F, we are in Chimera. Then we are in Chimera 11, here video 6, and here resources video. Then now we can try to open the structure, the PGB structure of the receptor, Then we click on OK. Here we have the structure of the receptor in Chimera, and we can press iterative rebound and surfaces 3 and wait for the presentation. Not that presentation for molecular docking. We need rebound, iterative rebound. We need that presentation. Yes, I think that structure is better compared to the other. Now we comes and we're gonna open again, and we choose now the structure of the ligand, the PGB structure of the ligand. So, and as you can see here, the ligand and the proteins are in different position. Here I have the ligand here and the proteins here. Now I can perform molecular docking while the two structures are not closer to each other. What I need to do now is to move structure from one position to another position. In order to do so, I come here in movement movement mouse mode. I click on it and I change the movement mouse mode by move molecules. So I come here, I select that molecule and I try to move it. I use the right click to do so. Then I use the right click, and now I can use the left click to turn the structure, or the right click to move all the structure. You have a video here to you have a video here on how to perform this type of movement, or on how to move only one object, or to change the property of your mouse in Chimera. Okay, I think that position is better compared to other position, so I can start to perform the molecular docking now. But before doing so, I need to change the mouse mode, movement mouse mode in normal. Okay, then I can't move only one molecules or receptor now. In order to perform the molecular docking properly, you come here on tools and you go on surface binding analysis and you click on AutoDock Vina. You click on it. When you click on it, you'll have this window on your screen, and you have to set the output file. The output file must be in the same location like where you want to have the molecular result for the docking you are performing. Then you come here on steps and you are going to call it, for example, complex, then complex 1. Okay, now we have to choose the receptor. The receptor here is already the first protein, the first compound that we open in Chimera, and the ligand is the same compound, but the two compounds can't be the same. If it's the case, the software will say that you are not able to perform the molecular docking because the two structures are the same. The ligand and the receptor need to be different compounds. Now, concerning the receptor search volume option, here you have many types of insertion of receptor sites or search volume. You can use size search volume using button, or you can use center and coordinates. For example, if you come here and on center and coordinate and you type there 34, here 56, here for example 77, that is only an example, and center I choose for example 0, 0, and also 0, 2, and I come here. When I come here in the structure, when I click on the structure like that, you can see that a box appears. There is a box which appears a little far of our complex, our ligand and receptor, but we need to put that complex, that ligand, that receptor and ligand inside the box, or to put the box above this structure. Directly when we have this box, we can simply come here, we use our keyboard, you press Ctrl and you place your mouse a little bit far of the how can we call it, you paste it. Then why you see that the structure are not directly inside the box, what we do is to come here and click on search volume using, we can for example choose Ctrl+1 button, because in some practical case you can have a monitor which have already find the good coordinate for the box, knowing that using the practical guide and the instruction you can enter the corresponding coordinate of a cubic box englobing the two structure receptor and ligand directly. So in that case, we are going to do it manually. Then we come here. In order to modify the size of the box like you see in the screen, you are seeing in the screen now, I have to press Ctrl directly and use the left click of my mouse to increase following an axis. For example, if you consider that is X axis, Y axis, and Z axis, we can modify the structure like that, following each axis. That's how we can modify the box. Now, how to move the box totally and place the structure inside the box. In order to do that, we will go a little bit far of the cubic box, but still close to it, and you press Control and you press the left click of the mouse and you move it like that. Now the structure are probably together, but not yet. Then we have to modify it like that and make sure that the proteins and the receptor are all together in the box. We call this kind of docking blind docking, because you don't really know where the active site is already located in order to perform the molecular docking only there. But it's possible that with your monitor, when you are learning how to perform molecular docking, it specifies for you where the active site is located and which coordinate you are able to enter concerning the structure of proteins and the ligand in order to have the two structure mixed with each other. Okay, then here we have a box, and that's the structure of the box we have. Okay, as you can see now. And the coordinate for that box is that kind of coordinate. So for example, for your practicals, I can copy this coordinate and paste it in the guide. So when you arrive at this step, receptor search volume, you just have to enter this coordinate and the volume will appear directly or automatically like that. Or if you want, at the beginning, before enter the coordinate, you can directly click on resize search volume using Control button 1. When you use that command, you just have to come on the screen and make it a left click and define a box by yourself. Redimension each site by coordinate, maybe X, Y, or Z, as we saw previously. Then knowing that you already have the coordinates of the box like that, you just have to come here on the AutoDock Vina window. Make sure that the executable location is in your computer where the script program corresponding to AutoDock Vina is located. So having that, we can come here and click on apply. Click on apply. When we click on apply, you will see that the computer will automatically start with molecular docking by writing a lot of instruction in your computer, input file, output file, and something like that, and mentioning here in the command line like that the process is running. Knowing that the process is already running, you just have to wait that the docking ended. Okay, when the molecular docking is ended, you can have a window like that containing the structure of the main result you obtained. For example, here you can see that we have some example, some result. When we click on it, the structure here is moving like that. Now, you have to also know that the time taken by the molecular docking generally depends of the quality of your computer, maybe the properties of your computer. I accelerated the video previously in order to reduce the time of running processes. It can take, for example, minutes to hours depending on your computer. Now, we are going to perform another molecular docking. When we click on apply, we don't directly stop the molecular docking. We can click on apply many times and have many kinds of result. So we are going to just click on OK. If you click on apply 10 times, you'll have 10 result. If you click on apply twice, third, you'll have 2 or 3 result. We are not interested in. We are going to see, for example, what will appear if you directly click on OK. You click on OK, and we see that the computer will continue with the molecular docking tool like that, and at the end we end by running, which means that the computer is working. And now you wait. Okay, when the second molecular docking is ended, you have another window like that containing this result. Okay, I have the two sides of result, and as you can see here, we have minus 9.7, minus 9.9, and here minus 9.9, minus 10.0, minus 10. Minus 10.0, and the best result is the lower result. Then how can we visualize the different structure here? Remember that our first structure was that structure. We call it that structure no value. Then we can see that the name is Nova, and this one is still Nova, but according to its position, model 3.4, and there is Nova in model 4.5. Then we are going to see the influences of each model. Here, when we click on this one, we can see that the position changed. Position changed here. Let's see it again. Minus 9.7, minus 9.7, minus 9.7. The position is changing. Minus 9.6. Here, the structure in minus 9.6 is practically mixed with the structure, with the other structure, with that structure in model 4.5. Then let's check the result, and we can see that here the minus 9.6 and minus 9.8 are really close to each other. Minus 9.6, minus 9.6, minus 9.5. That is the different position. We can also have a movie on how these structure are moving inside the active site of the proteins. Then the software tries to find the active site and insert the ligand there in order to have the molecular complex. Then there's the result. We can stop it, and we can visualize the result related to the first one, the model 4.1. Model 4.1 has this compound minus 10.1, which has the best score on the best position. We can check it here, minus 10.1, and here we can check the other position by playing the video. Okay, here's the different position, and one position, minus 9.8, minus 9.6, and the different position. So we have these different position. Okay, now we have here the ligand in the initial position of the ligand. Now, how to save the molecular complex with the best conformation or with the best configuration between the ligand and the receptor? What we have to do is just to come here and remember the code of the main result, of the lower result, for example, which is minus 9, minus 10.1. Then I come here, minus 10.1, model 4.1. I have to save this model. We can also save all the view doc obtained in order to use them further when you want to for example, report the different energies related to complexes. But what I did generally in that case is to use the screenshot command in my computer. Then I use this command to make a screenshot of the screen and save it. So I'm going to save it while I'm working in resources, molecular docking steps. Knowing that here I have result, then I can save it as result. I can save it as result, knowing that maybe 1 year later I can come here and find where or what were my results, if I can see like that. Then I come here and I remember that the best model is model minus 10.1, model 4.1. So I come here, I go on save PDB. In that window, I can increase that windows. I come here and make sure that the save mode is save multiple models in a single file. Make sure that you have it in a single file. If you don't have it in a single file, you'll download or you'll save the bad folder. Now, to have the two files to save, you have first the proteins and next you have the best model. In order to select the two together, you press Ctrl and you find the best model. The best model is model 4.1. Click on it, knowing that you have saved the two. You selected the two model, and you come here, you name them. Look, so you are going to say to name it OCM1, for example, and make sure that it is in molecular docking steps, and we click on OK. After that step, now we can come here in our computer where we have resources. Okay, we can see now in molecular docking steps, which was empty at the beginning of the video. Now we have some folder there, and we can see that we have here the structure of a complex OCM1. We are going to open it. When we click on it, as you can see, we have that structure. We have that structure here in Discovery Studio, and that structure contains both the ligand and the receptor proteins. And remember that in the beginning we have that structure has the proteins receptor without any ligand inside it, and here we have the structure of the receptor of the ligand pattern. We have the structure of the ligand. If you use the stick mode like that, you can see that we have the same structure here, and here we have the receptor, and here we have a complex where both the receptor and the ligand are mixed to each other. And as you can see here, the ligand is right, but here the ligand makes some torsion, and that is because we optimize the structure before performing the molecular docking. We call that kind of docking flexible docking. So all the two structure are all the two structure can change their forms while we are performing the molecular docking. Then we have these two structures, and we can start now to visualize different interactions and present them in a paper or in our memory thesis or other kind of production, in order to visualize the different interaction between the complex inside the complex, which means between the receptor and the ligand. You come here in receptor ligand interactions and you click on show 2D diagram. When you click on show 2D diagram, you can directly have a diagram like that. And when you come here and you click on ligand interactions, you can directly have a scale. You can directly have a window like that with interactions in 3 dimensions. Okay, now how to present this kind of interaction, how to analyze them, and so on. You can see these elements in our other video. Then when you want to save the structure of the initial structure of your complex from the beginning, in order to have an image of it, then you come here You open it again, and when you open it, you comes down here, script visualization publication quality, paste it like that. You can change or customize the ligand, display style, ball and sticks, custom one element carbon only, color yellow, okay, apply, okay. Then you have a structure like that with carbon atoms in yellow and others atoms, they are carbons, nitrogen, hydrogen, oxygen, and others. You want to save that image, you come here, file, save as, and you choose here, you choose image file, COCM, and you choose a good resolution definition. For example, we are going to choose 55 inch and save it. We took a little time and give the result. Now we can come back on Chimera. When we are on Chimera and when you want to save the different result, we can come here on save as. We are here and we have to save this data. We come here and save file name, model. We can call it model 4 result, model 4 results, and save it. And we call that one no reward. We can call it model 3. We can call it model 3 result, model 3 result. Now, how to remove the bad structure? Because if you select directly control like that and you press on them, you can see that I will remove only the best one. Here in the active site, you have a lot of compounds mixed with others like that. Then how to remove them? You come here and you click, after selecting them, the structure that you want to eliminate, you click on purged. When you purge them all, you have that structure which is the less structure, the best one, and you can save it or you can rewrite it like as model 4 result. I will modify it best. I will add here best model 4 result and click on save. Now I can cancel that window, and knowing that these windows show some bad result that I don't need to save them, I'll just purge all these results like that. I select them all, press Ctrl and use the left click of your mouse, and at the end you press on purged. Then all the structure are purged and you click on them. The first structure, this blue structure of no value is the initial structure. Then I come here on select residue, not chain. I'm coming on hurt, because after molecular docking, this element become a hurt, and the complex and the ligand and the receptors in the computerized position are considered as one entity, and this one is an hetero entity compared to the others. Then after selecting it, you go on action, you go on atoms, bonds, and you click on delete. You delete it, and now you only have the good structure of the proteins and the receptor mixed with each other. Now, how to get or to have an image of that complex, maybe in a good quality? I can come here on favorite and go to preferences, and inside preferences I go on not general but on background. Click on background. I will choose the white color, I think that we have a video here where we show how to present it. Okay, we save it and we close. The background now is a white background, and you have a structure like that where you have the ligand and the receptor mixed with each other. And when you want to save it, you come here, file, save image. On the save image file, you come here. I already have a high resolution here, and PNG file. I have a problem with that structure, I don't know why. Okay, then you have image. We are going to call it image1 PNG. Unit centimeter here, but I can also choose inch, and I'm gonna use, for example, 30, not 30, 40, as previously 50 inch, and here modify it automatically. And now I need to press save. I'm using here a high resolution for that image, so you can change this kind of resolution when you are doing your optimization. And you can also choose transparent background if you want to superpose the structure that you obtained or not. Then I'm going to save. It will take a little time by rendering the image in high resolution. Then after that, you go on save image here once again, and we are going to call it image 2 and choose transparent background, and we are going to click on save it. You have to wait that the high resolution image will be generated. While waiting for that resolution to be obtained, so that high image to be obtained, we can save that one as the view file, save as the view file that we can use once again in the next step of our work. And I can close that window. So know that we have here the structure of the ligand, here the structure of the receptor, and we have here the structure of the two mixed in a complex. Then we have performed a molecular docking. Here we come on images. There was the two-dimensional structure of the ligand, here the three-dimensional structure, here the receptor, and here we have the structure of the complex. What is the structure of the complex? We are going to see where is it. The structure of the complex is not here. We are here, and we can click on OCM 1 images. Then we have here images. These images in molecular docking, we have that image. That is the image without any background. As you can see, the quality of the image is really good without any things behind the image on the background. And you can use that image in maybe white background, red background, depending of you. And that image on the white background wasn't obtained. I don't know really why. Maybe my computer capacities are really low for that high quality image. Then here we have OCM1 image, the image obtained with Discovery Studio, and as you can see, the properties are really good. The quality of the image is really good. Then that is how to perform a molecular docking and have the structure. There is a structure in three-dimensional position without background, and here with background using Discovery Studio and Chimera. Okay, thanks for watching, and don't forget that at the end you have to analyze this result, the result concerning the energies of the images you obtained to justify why you choose the lowest energy, what does that means when compared to others, and how to analyze the different interactions involving.